Hi everyone, welcome to my channel Chemistry Tutorials by Kiranmai. In previous videos, we discussed about Bohr's postulates and we also discussed about Bohr's atomic model for hydrogen atom. In today's class, I am going to discuss about the explanation of line spectrum of hydrogen by using Bohr's model or Bohr's postulates. Explanation of line spectrum of hydrogen atom. Before going into the topic, let's have a brief discussion about the hydrogen spectrum. This is the diagrammatic representation of hydrogen spectrum showing various spectral lines which are named after their discoverers Lyman, Balmer, Bastian, Brackett, Fun. To explain the spectral lines which are obtained in visible region, Balmer gave an expression nu bar is equal to 1,09,677 into 1 by 2 square minus 1 by n square. That is, wave number is these spectral lines follow an expression, that is they give a wave number which is equal to 1,09,677 into 1 by 2 square minus 1 by n square. Here n is greater than or equal to 3 and the spectral lines which are obtained in ultraviolet and infrared regions also follow the expression given by Rydberg. Wave number is equal to 1,09,677 into 1 by n1 square minus 1 by n2 square centimeter inverse. Here n1, if n1 have a value of 1, then it explains the spectral lines given by Lyman. If n1 equal to 2, Balmer series is explained. n1 equal to 3, Bastian series. n1 equal to 4, Brackett series. n1 equal to 5, Fun series. So here n2 is n1 plus 1 greater than n1 plus 1. So see here n1 equal to 2. Here n2 is equal to 2 plus 1, 3 equal to 3 or greater than 3. Here n1, n2 means it will have a value of n1 plus 1 or greater than n1 plus 1. So this formula is given by Rydberg to explain the spectral lines in the hydrogen spectrum. According to Bohr's postulates, this expression is derived. That is, Bohr gave a mathematical explanation for the hydrogen spectrum, line spectrum of hydrogen atom. So Bohr gave a mathematical explanation for line spectrum of hydrogen atom. Let's discuss this. According to Bohr's postulates, electron revolves round the nucleus in a circular orbit, and as long as when the electron is present in the particular orbit, its energy is constant. It is only changed when electron moves from one orbit to other orbit. Let us see, these two are orbits or stationary states. This is lower stationary state. Let us name it as Ni, and it is higher stationary state. Let it be Nf. If electron move from lower stationary state to higher stationary state, energy or radiation is absorbed. If electron move from higher stationary state to lower stationary state, energy or radiation is emitted. This is the second postulate given by Bohr. So he also gave a formula to calculate energy of the stationary states. So to calculate the energy of stationary state, En is equal to minus RH into 1 by n square. This is the formula given by Bohr to calculate the energy of electron present in nth orbital. If we take Ni orbital, its energy is Eni is equal to minus RH into 1 by Ni square. Similarly, energy of this orbital ENF is equal to minus RH into 1 by NF square. The difference between these two energy states is delta E is equal to energy of this ENF or EF minus ENI or minus EI. If we substitute these values, these formula values in this formula, we get ENF minus RH into 1 by NF square minus RH into 1 by NI square. Minus of minus A is nothing but plus A. Similarly, minus of minus RH becomes plus RH. So, minus RH into 1 by NF square plus RH into 1 by NI square. If we write minus A plus B, it is also equal to B minus A. Similarly, here we are writing it as RH into 1 by Ni square minus RH into 1 by NF square. Means RH, when we take it as common, RH into 1 by Ni square minus 1 by NF square. Here RH is the Rydberg constant. Rydberg constant value is RH, Rydberg constant, is equal to 2.18 into 10 power minus 18 joules. So here we are substituting the Rydberg constant value. So delta E is equal to 2.18 into 10 power minus 18 into 1 by Ni square minus 1 by N square. This is the formula to calculate the difference in energy. Let it be the first equation. According to Bohr's third postulate, delta E is equal to h mu. That is the energy. It will be equal to photon energy, h mu. So, substituting the values of delta E and Planck's constant h in the given formula gives us the formula to know the frequency of the radiation. Here h is Planck's constant, which has the value of 6.626 into 10 power minus 34 joules second. And we also know delta E formula. Delta E equal to 1.18 into 10 power minus 18 into 1 by Ni square minus 1 by Nf square. So substituting this in the equation, delta E equal to h mu. So from this equation, mu is equal to delta E by h. So delta E equal to 2.18 into 10 power minus 18 into 1 by Ni square minus 1 by Nf square by Planck's constant value 6.626 into 10 power minus 34 joules second. So if we calculate this one, we'll get the value of 0.32900 into 10 power 16 into 1 by ni square minus 1 by nf square. We can also write this one as 3.29 into 10 power 15 into 1 by ni square minus 1 by nf square. This is the formula for calculating the frequency of radiation which is absorbed or emitted by the electron. And in terms of wave number, if we express the frequency, by using the frequency, we can calculate the formula for wave number. So we know the formula, velocity of light c is equal to nu by lambda. Nu into lambda, frequency into wavelength. So by using this formula, wave number means wave number nu bar is equal to 1 by lambda. Number of wavelengths per unit length is known as wave number. So from this formula, 1 by lambda is equal to nu by c. Nu by c. See here. We also know the frequency and velocity of light c is equal to 3 into 10 power 8 meters per second. So by substituting this one in the formula, 1 by lambda is nothing but nu bar. So nu bar is equal to frequency by velocity of light. Frequency formula we already got. 3.29 into 10 power 15 into 1 by ni square minus 1 by nf square by velocity of light 3 into 10 power 8 meters per second. So here we'll get, here the value is joules and this is joules second. Joule get cancelled, this is second inverse. So here second inverse is nothing but 1 by second, meters per second by 1 by second. Here we can write it as 1 by second into, this one will get reciprocal, second by meter, cancel. So per meter, units will be per meter. And when calculate 3.29 divided by 3, we get 677 into 10 power 8. When we'll take this one into numerator, it will become minus 8. 15 minus 8 means 7 into 1 by ni square minus 1 by nf square. Here units will be meter inverse. If we convert meters into centimeters, we'll get 1.09677 into 10 power 7 into 1 by ni square minus 1 by nf square into 1 by 10 square centimeter inverse. See here, 1 meter is equal to 100 centimeters. 1 centimeter is equal to 1 by 100 meters. 1 centimeter is equal to 1 by 10 square meters. 1 centimeter inverse is equal to 1 by 10 square centimeter, 10 square meter inverse. Okay, so 1 meter is equal to meter inverse. So we are calculating it as sorry, 1 meter equal to 100 centimeters. So we are changing this one into centimeters. We'll get 1 by 10 square centimeter inverse. So 10 square. Here we get reciprocated, then we'll get 10 power 5. 1.09677 into 10 power 5 into 1 by n I square minus 1 by n f square centimeter inverse. So after removing point we get 1,09,677 into 10 power 1,09,677 into 1 by n I square minus 1 by n f square centimeter inverse wave number. This is the same formula given by the Rydberg to explain the spectral lines in the hydrogen spectrum. So by using Bohr's model, Bohr can explain the spectral lines in the hydrogen spectrum mathematically. So this is today's class about explanation of line spectrum of hydrogen atom. Hope you understood this topic. If you have any doubts, let me know in the comment section, and if you like this video, please like the video. Thank you.